Hello everyone, myself Dr. Balamurgan, working as professor in the department of ECE. Today we are going to study about how to write the VHDL program very easily. So let us see about this HDL first. HDL, H stands for hardware, D stands for description and L stands for language. So HDL is called hardware description language. We know many languages are there like C, C++, Java, etc. So this language is something different. This language is used to design the hardware circuit, digital circuit. So the popular HDLs are VHDL, Verilog HDL and System C. So by using any one of this language, we can able to design the logic or digital circuit. So let us see about this VHDL first. So VHDL, we have already seen about HDL, H for hardware description language. So for this V alone, we have a big name, very high speed integrated circuit, very high speed IC hardware description language that can be used to model a digital system. So let us see about the modeling of VHDL. We used to call this as various styles of writing VHDL code. So there are three modeling available. In VHDL programming, that means three different styles to write the VHDL code. So the first one is data flow modeling, second is called as behavioral modeling, third is called as structural modeling. So let us see one by one. Before that, let us see how to write these different styles of VHDL. So first one is data flow modeling. So when you are writing a program using this data flow modeling, you should keep this key point in mind. So the first key point is use logic output of a circuit. So if you are writing the program using data flow modeling, we need only the logic function, we need only the output function. For example, this is an AND gate, it has two input A and B and output is Y. We know the function of AND gate, Y is equal to A and B, A dot B. For writing a program in data flow modeling, we need only this. We need only this output Y equal to AB. That I can write down as Y is the output. I have to write like this. See this format. Y is the output. A lesser than symbol equal to. It looks like an arrow mark. And here I have to write the function A and B. A and B. So what is A? A and B are the inputs. And what is this? And is the keyword available in the library of VHDL. So if you write A and D, it will perform the AND operation by taking the nearby variables. Okay. So that's all about this data flow modeling. Only 2 points. One is you have to, the main point is you have to concentrate, you have to take only the output function, output logic function. Then second one, you should write it in this form. Okay, so the data, input data is flowing to the output. Okay, so data flow modeling. Let us come to the next one, it is called as behavioral modeling. Okay, so first point, here you have to use the truth table of the logic circuit. For example, if you are designing an AND gate, the truth table of AND gate is like this, for this gate. AND gate is like this. So we have to concentrate on this truth table. We are not concentrating on the logic output function, but here we are concentrating on the truth table of the circuit. And the second point, you should include the loop statements, or we can say it is called a sequential statement, like if statement, case statement, for statement, etc. This is the second point. So the third point, you have to include a keyword called process. You have to include a keyword called process. So these 3 points you should keep in mind to write the VHDL program in behavioral modeling. First point is truth table. You have to use the truth table to write the program. The second point is you have to use any loop statements. The third point is you have to use process, that keyword, in your program. The last modeling is structural modeling. This modeling is something different than the other 2 modelings. Okay. So here in structural modeling, you have to describe or define each and every component inside an IC. For example, this is an IC. It has components like 2 AND gate and 1 OR gate. Okay, like this. Here we are giving input like A, B, C, D, and this is the output. So in this structural modeling, you have to define each and every gate inside the IC. For example, in this IC, you have 2 AND gates and 1 OR gate. So you have to define AND gate and OR gate in your program. So this is about the structural modeling of VHDL. So let us see about the structure to write a VHDL code. So if don't bother about the size of the program, it may be a big program or a small program. Every VHDL program should have these 3 declaration in the program, right? So first declaration is called as header declaration. Second is entity declaration. Third is architecture declaration. So every VHDL program should have these 3 declarations. Let us see one by one. So the first one is called the header declaration. Here you have to declare the library statements like library IEEE, use IEEE dot std underscore logic underscore 1164 dot all. So these first 2 lines are mandatory for each and every VHDL program. Without these 2 lines, the VHDL program will not work. Okay. So what is the first line? The first line says library IEEE. Actually, the VHDL program is standardized by this IEEE organization. So the first line of every VHDL program should have this word library IEEE. So for example, for your understanding, I can say, so we have library in our college. We have, in that library there are many racks available. So one of the rack name is IEEE. Assume one of the rack name is IEEE. So this rack is, in this rack you have many shelves like this. So one shelf is allotted for this VHDL program and the number of that shelf is 1164. The number of the shelf is 1164. This way you can understand it. We have a library. That library there are so many racks available. One of the rack name is IEEE. In that rack you have one shelf that is allotted for VHDL programming. The shelf number is 1164. Okay. Coming to this, the first line of every program should start with library IEEE, a semicolon, and the second line it will start with use. We are using this IEEE, use IEEE dot std underscore logic underscore 1164 dot all. See, we are using this IEEE. This std underscore logic is nothing but it denotes a single bit, because we are using bits here, our input, output, everything in terms of bits only, right? So here std underscore logic means a single bit, and 1164 is nothing but, I told you, this assume this is the library name, 1164 dot all. This all stands for that we can use whatever the functions available in that 1164 we can able to use. Meaning in this IEEE rack the number here is 1164 for VHDL programming. There many books are available. We can able to access or take all the books, so that we are mentioning here dot all. These two lines are not mandatory, but for your programming, if you are performing, or if you are writing any arithmetic code, we can use this header file arith. You use IEEE.std underscore logic underscore arith.all. If you are performing or if you are using any signed, unsigned bits in your program, you can use this header. Use IEEE.std underscore logic underscore unsigned.all. But these two are not mandatory. If it is needed, you can use it. But these two lines are mandatory for every VHDL program. So let us see about this NDT declaration. The second part of VHDL program is the NDT declaration. So this is the syntax of NDT declaration. So see this, first word is NDT name. See, I have mentioned this name in green color. So you can give any name here. You can give any name. Yes. Port, second line is port. Here you have to declare the input and output functions, input and output variables. Okay. Then NDT name. See this NDT name, this one and this one should be the same name. And one more point, that you have to use a single word. There should not be any space between that word. If you cannot use two words, you can use a single word. Okay. So this port modes are in, out, in, out. So here we can, these are the keywords. In means input port, out means output port, in, out means input and output port. Sometimes the output of one circuit or device will be the input of the next one. At those cases, we can use this in, out keyword. So NDT name is port. Here you have to declare the input and output variables, then NDT name. So those the keywords are in, out and in, out. Okay. So the third one is architecture declaration. This is the main function of the VHDL programming. So see the syntax. We are writing the word architecture. We are writing the word architecture, and architecture name of NDT namers. Begin, you have to declare the function here, and end architecture name. So let me tell you once again. So the first word is architecture. The next is architecture name. See the color, it is given in a different color, of NDT name. This name we have declared in the NDT part. The same name you have to use. Yes. Begin. Here you have to declare the functions, main functions. Then end architecture name. The same name again can tell you it should be a single word. That's all about this architecture. We will see this. So let us see an example. Here we are going to design this IC. The input of this ICs are A, B and C, and output is D. Here this temp is nothing but it is signal. Signal means the output of one gate will be the input of the next gate. Right? So we have named this as temp 1 and temp 2. So now we are going to write the VHDL program in data flow modeling. So whatever the style may be, it will be having three parts. The first part is header declaration, second is entity declaration, third is architecture declaration. We will see one by one. So now we are going to write the program using data flow modeling. This is the IC. So what is the logic function here for this IC? D equal to AB into AC. This is AB, this is AC. Right? So AB dot AC. So for this only we are going to write. So for writing a program in data flow modeling, you have to use the logic function. Correct? So let us see one by one. So what is the first line? First line of the program is library IEEE. I told you that every program starts with this line. Second line is use IEEE dot std underscore logic underscore 1164 dot all. These two lines are mandatory. And next we are coming to this entity part. So entity, the syntax is entity name, yes. So entity name I have given us and underscore gate. It's a single word. Correct? So you should not use the word like and, because you should not use this word as your entity name, because this and is available in the library of VHDL. It will perform and function. Okay. So you should not use the keywords. Right. So entity name is port, open bracket, what are the inputs? A, B, C, colon, in, that is a keyword, std underscore logic. Meaning is A, B, C are the input variables, colon, in is the input. We are saying that this is our input, and std underscore logic. What is std underscore logic? It means a single bit. So this ABC we can able to give only single bits. Okay. So the semicolon, then D is our output. D colon out is a keyword. We are saying that D is our output. std underscore logic. What it means? That D is also a single bit. Then you have to end it with AND gate. End it with entity name. So this name should be same. AND gate should be same. The next one is the architecture part. So what is the first line of architecture? Architecture name of entity name is. So architecture name, this is a different name I have given, like data flow. Of entity name is. So the green color is the architecture name and this red color is the entity name. Yes. So now I am going to write the function. D equal to, see this arrow mark, is equal to A and B, A and B. In bracket you have to write and A and C. See, A, this is and, B, this dot is and, again A, this dot and this C. So this is the function we are writing. So D is the output, which is equal to A and B and A and C. It's nothing but like this. D equal to A dot B dot A dot C. Okay. Now we can end it. End data flow. So we are ending with that same architecture name. But here one line is missing. Actually, before writing this function, you should use the keyword called begin. How to use the keyword called begin. Okay. So without that it will not work. So whenever you are writing the function like this, you should write it with the keyword begin. Okay. So this is the way we can write the VHDL program in data flow modeling. The next one is we are going to write using behavioral modeling. We will see this one in the next session. Thank you.